This is the systems level overview of the control scheme for the Lunabotics robot, Team Selene 2021. The input method we're using is a PlayStation 3 controller, which communicates over Bluetooth to an ESP32 microcontroller. In this case, our ESP32 is acting as a telnet client. This is in the operator area. A short distance away, we have a wireless local area network access point, which is just our router, not connected to the internet, just solely as a local area network. And that is connected to our telnet server, which is another ESP32 that's present on the robot, and it's going to communicate the information from the PS3 controller to an Arduino Mega over UART. Our transmission protocol, of course, since it's a telnet system, is TCP. Therefore, there is some handshaking going back and forth between client and server to ensure that our data integrity is there. So here is our, I'm gonna bump this back. Here is our wireless local area network access point. Here is the telnet client, PlayStation 3 controller, obviously. And then here's the server, and then our Arduino Mega. The UART setup here is coming from this level converter, since this is a 3.3 volt device and this is a 5 volt, just to get them on the same level. So this is what the server is seeing now. So the client is transmitting nothing because, or it's just zeros, because the PlayStation 3 controller is not connected. So just to show you what happens, you press the PlayStation button and then it connects. So the way I've been transmitting this data to be somewhat efficient with my data is in hexadecimal. Computer went to sleep, but like I was saying, everything's transmitted in hexadecimal. I was doing integers at first, but I can transmit the same amount of data in 2 characters versus 3 for integers. So this is the format. It's we're delimited by these dashes, and then there's a end of transmission period right there, which is used later on the Arduino Mega. The transmissions occur 10 every second, and that was to maximize our data and minimize our points lost in the Lunabotics competition. So that data is, so going back to here, controlling the controller sends data to this client, and this is just connected to here for power. There's no data going across that. So this wirelessly connects here, and then that is wirelessly connected to this, which then takes that data from the telnet client and pipes it down into this level converter, pipes that to the RX pin right here after being converted to 5 volts for the digital signal, and then that data is sent on here. Notice this is what our serial monitor is showing right now, and the formatting is different. I've converted it back into integers. So what we did was we took in the serial information at a baud rate of 9600 from the ESP32, and then that information was, we use this read bytes until the period, so that's why we use the period right here, and we assigned it to this con string, and then we copied all that data into a new array. So it copied everything from here without the period into a new array. Then we go down here and we use the string token function, and we passed in our delimiter variable, which is the dash, and the new array. Then we assigned all these values to the values that are sent from the PlayStation 3 controller. These values are then passed through this function extract, which because the values are sent in hexadecimal, but not really hexadecimal, they're just characters that represent what the hexadecimal should be. What we had to do was break it into two parts. So in this case, we'd break the 8 and the 1 apart, and then we use this function convert to hex, which it looks through and finds whatever the case for, if in this case, if we're dealing with 8-1, we look for 8, which would be, it would return an 8, and then 1, which would return a 1, and we bit shift the return value 4 times, and then OR it with the converted for the second, which would be the 1 in this 8-1 case. The reason this is done is because you can see down here when we get into like the hex for A, the return type is going to be 10, and that doesn't really fly when you're trying to do it directly. But once we get all this data out of here, we send it back up here, and we're just extracting, and then down here these we have like some binary inputs from the buttons, but what happens when we run that through the extract is since there's that bit shift 4 over, it makes our binary values 0 or 16. So then what we did was we shifted it back 4, and it's 0 to 1. So we got all that back in integer, and so you can see right there, everything working just fine. Let's see, we got left trigger and right trigger also, and we got our buttons, circle, square, triangle, etc. And yep, that's about it. This information is going to be used on the Arduino Mega to talk to some higher level code to run things such as the drive motors or the mining wheel or the linear actuators to raise and lower the wheel once those are built, of course. But yep, thanks for watching.